Hello and welcome. In a groundbreaking move toward technological self-reliance, China has successfully tested its self-developed satellite operating system in orbit, a major milestone that may redefine the future of space autonomy. The system, known as OpenHarmony, is a simplified version of Harmony OS, originally developed by Huawei, to replace Google's Android after U.S. sanctions in 2019. While Harmony OS was designed for smartphones and IoT devices, OpenHarmony has been tailored specifically for mission-critical platforms, requiring extreme responsiveness and stability such as satellites. The test took place aboard a small CubeSat satellite named Dalian-1 Lianli, which was deployed into orbit from the country's Tiangong space station. After more than 1,000 hours of operation, results showed a significant improvement in the satellite's performance in terms of speed, system stability, and overall efficiency. This development is more than just a software success story. It reflects a strategic pivot away from reliance on Western technology, especially in national security sectors like aerospace. Previously, Chinese small satellites commonly used open-source operating systems, such as FreeRTOS, which were not originally designed for space missions and required extensive modification. On top of that, access to these foreign technologies has become increasingly uncertain. Due to escalating international trade restrictions, OpenHarmony represents a full-stack domestic solution not only in software, but also in hardware, enabling full control over critical space mission components. This is a huge advantage in an industry where most nations depend on a mix of international suppliers for satellite parts and embedded systems. So, what exactly does OpenHarmony control on the Dalian-1 Lianli satellite? It powers and coordinates several essential instruments: magnetometers, solar sensors, attitude control systems. These systems demand microsecond-level responsiveness, which OpenHarmony has been able to provide consistently in orbit. That precision enables faster data processing and more frequent transmissions back to Earth, ultimately increasing the mission's success rate and data fidelity. An interesting detail in this test is that Dalian-1 Lianli was stored aboard the Tiangong space station for 253 days before being launched. Despite long-term exposure to the harsh space environment, both the satellite's hardware and OpenHarmony OS activated flawlessly upon deployment, a promising sign for future long-duration missions. Additionally, Dalian-1 Lianli is equipped with a high-resolution camera system, capable of capturing Earth imagery with a resolution fine enough to detect objects smaller than 1 meter on the ground. These images are already being used to support urban planning and coastal development projects, with a particular focus on city-scale mapping and infrastructure monitoring. OpenHarmony is maintained by the OpenAtom Foundation and is steadily expanding its application footprint beyond space. It is already being used in embedded systems, industrial automation, and electronics, where responsiveness and reliability are critical. This test not only proves the maturity of China's space software ecosystem, but also sets the stage for a new class of autonomous, domestically controlled satellites. In an increasingly competitive, geopolitical and technological landscape, such independence may prove essential. With OpenHarmony's success in space, China is signaling its intent to own every layer of its tech stack, from silicon to software, and this mission is just the beginning. Thank you for watching, and stay tuned for more updates. From the edge of innovation